Hello everyone, happy to see you here on my channel. Hi, I'm Mathematics, and today we have a really great challenge, 3 to the power x plus x equal to 11, and we need to find our x. I know that a lot of students can solve this challenge by inspection, but in terms of math, we're interested in a solution to this challenge. So in this video, I'm going to fully explain how we can solve this correctly and step by step. First of all, let's bring this x from our left side to right side. Okay, so what do we have as a result? We will have the next thing. We will have 3 to the power x still on the left side and equal to 11 minus x. Right now let's change position. It will be understandable for you when we change position, so let's write this thing on the left, this one on the right. It changed nothing because we have all the time equal sign, so we have 11 minus x equal to 3 to the power x. Okay, right now let's divide both sides by this 3 to the power x. Okay, so we divide in both sides by 3 to the power x. As a result, what do we have right here? We have a fraction, so we have 11 minus x over 3 to the power x equal to 3 to the power x over 3 to the power x. Really great. And right now we can easily cancel this 3 to the power x on the right side, because we can easily do this because we have the same numerator and denominator, the same expressions. But on the right side, we can also rewrite it in another way. We can also rewrite it. We can easily bring this 3 to the power x from our denominator to our numerator, yeah? But from school, you need to know if we have, for example, 1 over b, this will be equal to b to the power minus 1, yeah, when we bring this from our denominator to our numerator. As a result, what do we have right here? We have 11 minus x times 3 to the power minus x, yeah, we bring in this 3x to the numerator, and equal to, right here we have 1. Okay, this is our first step. We rewrite this expression like that. Right now, let's multiply both sides by 3 to the power 11. Okay, let's do this. In 1 minute, you will understand why I do this. So we just multiply both sides by 3 to the power 11. Okay, as a result, what do we have right here? We have 11 minus x on the left side times 3 to the power 11 and times 3 to the power minus x. So I write this 3 to the power 11 right here in the middle, and equal to 1 times 3 to the power 11. Okay, really great. Right now, we have the same basis. As a result, if we have multiplication right here, we can easily add our powers. So I hope you know this school property. If we have the same basis, we have multiplication, so we can easily add our powers and we can write it in one base. Okay, so as a result, 11 minus x times 3 to the power 11 minus x. Okay, 11 minus x equal to 3 to the power 11. Right now, I hope you see why I do this, because right now we have 11 minus x right here and 11 minus x right here as a power. And I hope you understand why I do this, basically because right here you need to know a little bit about Lambert W function. I try to apply right here Lambert W function, and a little small words about this function. Maybe someone don't know about this function. When we have, for example, a times e to the power a, when we apply Lambert W function from this expression, we have our a. Okay, so it simplifies us a lot. And basically, maybe someone don't understand this explanation about Lambert W function. When you have, for example, let's go with 5 times e to the power 5. When we apply Lambert W function to this expression, as a result, we will have only 5. Yeah, so this is equal to a, this is equal to 5. So basically, we need to have the same expression right here and right here. We have it right now, yeah? We have 11 minus x and 11 minus x, but we have 3. We need to have e right here. So as you can see, we don't have this expression that is really important for us in terms of Lambert W function. Right now, let's think a little bit how can we create this e right here, because we have 3. How can we create this e? I hope you know a really great property. If we have, for example, e to the power natural log a, this is equal to a, okay? So as a result, we can write this 3 as e to the power natural log 3, which is equal to 3. So instead of this 3, let's write this expression, e to the power natural log 3. Let's do this right now. Okay, so what do we have? 11 minus x times, instead of 3, we're going to write this, e to the power natural log 3, e to the power natural log 3. And we need to raise this by this, 11 minus x, okay? Because we still have this power, 11 minus x. Really great, equal to 3 to the power 11. Right now, we have the situation like a to the power x raised to the power y. So this is equal to a to the power x times y. We need to multiply this expression by this one if we want to raise this to the power 11 minus x. Okay, so what do we have right here? 11 minus x, so we still have this expression, times e to the power natural log 3 times this expression, natural log 3 times 11 minus x equal to 3 to the power 11. And right now, let's look closely. What do we have right here in this case? We have e, and we need to have e right here for Lambert W function. But if we look closely, we have 11 minus x. And we have 11 minus x right here. It looks like absolutely the same thing. It looks like everything is great, but we have natural log 3. So it's not the same expression right here and right here. We have natural log 3. And for this, in this moment, let's multiply both sides by this natural log 3. And we will have really great trick. So we multiply both sides by this natural log 3. As a result, what do we have right here? 11 minus x, okay? Well, let's write natural log 3 at first. Natural log 3 times 11 minus x, okay, times e to the power natural log 3 times 11 minus x equal to 3 to the power 11 times natural log 3. So we just multiplied both sides by this natural log 3, but with one really interesting moment right now. Natural log 3 times 11 minus x. Just keep in mind that this is our a, for example, yeah? And we have the same, natural log 3 times 11 minus x. This is also our a, and we have e. Let's look closely right here. When we have a times e to the power a, when we apply Lambert W function, we have our a as a result. And in our case, a equal to this expression. So finally, we can apply Lambert W function. So let's do this. So alone can complicate that expression, but I hope you understand it. So Lambert W function of this whole expression of natural log 3 times 11 minus x times e to the power natural log 3 times 11 minus x right here equal to Lambert W function of 3 to the power 11 times natural log 3. Really great, but as I told before, we have our case. This is our, for example, a, this is our a, and we have our classic case according to Lambert W function. So this expression on the left side is equal to natural log 3 times 11 minus x, and equal to this expression, Lambert W function of 3 to the power 11 times natural log 3. Really great. Right now, let's simplify this a little bit because we need to find our x. We can't leave it this question like that. We need to find our x from here. We have a complicated expression on the right side. But how can we work with this expression on the right side? Let's rewrite this 3 to the power 11 as 3 square. Okay, so instead of 3 to the power 11, we're going to write 3 square times 3 to the power, I guess right here we still have 9, yeah, because when we add it, we have 2 and 9, we have 11. So instead of this 3 to the power 11, let's write this expression, 3 square times 3 to the power 9. Okay, so we have natural log 3 times 11 minus x equal to Lambert W function of 3 to the power 2, okay, 3 to the power 2 times, let's write natural log 3 in the second position, and the next 3 to the power 9. Okay, right now, 3 to the power 9, 3 to the power 9, let's write it in another way. Let's create this e, let's try to simplify this expression inside this Lambert W function instead of this place. Let's write this 3 to the power 9 as e, okay, 3 to the power 9, we're gonna write as e to the power natural log 3, this is our 3, and we need to raise this to the power 9. So instead of this expression, let's write this one. Okay, let's do this right now. So what do we have right here? Natural log 3 times 11 minus x equal to Lambert W function of 3 square equal to 9, 9 times natural log 3 times 3 to the power 9 equal to this one. Okay, so we have e to the power natural log 3, and we raise all of the thing by the 9's power. Really great. Right now, the final step, we need to multiply this natural log 3 by 9 because we can raise this to the power 9. We need to multiply it. Okay, as a result, so we have right here natural log 3 times 11 minus x equal to Lambert W function of 9 times natural log 3 times e to the power 9 times natural log 3. Really great. Right now, 9 times natural log 3, for example, this is our, let's go with c, and we have the same expression right here, 9 times natural log 3, this is our c. Basically, on the right side, we have Lambert W function of c times e to the power c, which is equal to, which gives us only c. As a result, on the right side, we have only this expression. Okay, so right here, natural log 3 times 11 minus x equal to 9 times natural log 3. And the final step, the easiest step, I like this step the most, because we can cancel this natural log 3, and as a result, we have like very basic equation, 11 minus x equal to 9, and from here, our x equal to equal to 2. This is our solution to this challenge. We can also check this solution. What do we have in the beginning? We have 3 to the power x plus x equal to 11. Let's plug in this x equal to 2. So we have 3 square, yeah, right here 3 square plus 2 equal to 11. Yeah, this is absolutely correct solution. But I hope you understand why we can't solve this challenge by inspection. We have right here x equal to 2, because just agree with me, when you solve this challenge like that, when you write that the answer is x equal to 2, when you solve this challenge like that, this is really bad thing in terms of math, because as you can see right here, we solve this challenge in a lot of lines. We have more than 15 lines, 1, 2, 3, 4, like more than 10 lines. As you can see, a long and complicated solution. But when you solve this challenge like that, when you write that x equal to 2 and you leave it like that, you solve this challenge by inspection and you go to the next question, this is really bad thing in terms of math. So you need to know what is the correct approach, correct property, and this is really great question to train your, to practice your Lambert W function, because as you can see, we apply this Lambert W function 2 times. First time we applied it right here, and the second time in the end of this expression. And this is different cases, because right here we create the expression which is really great for Lambert W function, and right here we in a reverse way we do this. We create that expression which is also really great to apply Lambert W function. Yeah, so this is really great question to practice Lambert W function. You can also do this. You can also pause the video. You can also solve this challenge by yourself. You can also write your solution on the paper, and you will check with my solution. Of course, solution is a great part of this question, because this is hard challenge, and it's really great you to practice this question, because this is not that easy question. When you solve the challenge by inspection, this is very easy for you because you solve it in a 2-line, but this is really bad thing in terms of math, also for you and for your teacher to look at this solution, which is really bad. You can also check your solution according to this inspection method by basically a correct solution according to Lambert W function. You can see right here. So thank you for your time, thank you for your support. Write your question down into the comment section, write your notes about it, write your thoughts about this challenge. It will be really interesting to read about it. And thank you for your time. Have a great day. See you in the next videos.